Welcome, my fabulous chemistry students. Periodic table video 3. Today we delve deeper into what we call the groups of the periodic table. When we're done with today's video, you're going to be able to name all of the main groups and tell me a little bit about their properties. Okay, that gives each of them, makes them each unique and special in some way. All right, so what's so special about a group anyways, you say? Well, the elements that are in the same group generally have very similar properties. As we just learned in the last video, as I go down a group, I have the same number of valence electrons. That's going to be a major player in this, okay? Today's carrot or Easter egg, if you will. This is what I want you to do. After you're done watching video 3, I want you to come say, Mr. Milks, I watched video 3, ask me a question. And I'm going to ask you a question somewhere in video 1 through 3, and you're going to answer that question for me without a problem, and you just earned yourself a STEM buck, all right? Here we go. On to the notes. Group number 1 is called the alkali metals. Alkali metals. We can also call that a family. A group could be a family. So remember, those two things are synonymous, right? We're going to find that they all have one valence electron. They very easily want to lose that electron to become a positive ion. And that positive one is what you see up in the upper right-hand corner in the periodic table, right? They are very, very extremely reactive. Just boom, real quick with water, okay? And there's water everywhere. They contain the most reactive metal probably in francium. And because francium is very rare, then we say, maybe cesium is what we'll go with. But francium is actually the most reactive element on the periodic table as far as the metals go. Group number 2 we call alkaline earth. So here's how I like to remember this, ready? Because alkali and alkaline are very close. But ready? Alkaline earth, 1, 2 words, group 2. That's how I remember it. Alkali metals is alkali is one word, alkaline earth is 2 words, so that's group 2. Guess how many valence electrons I'm going to have? 2. Starting to get the hang of this, huh? They do prefer to lose electrons, so let's think about that real quick. This is the way I like to think about it. I need to get 8, and I have 2. Am I going to gain 6 or lose 2 to get to my valence shell of 8, right? So it's much easier to lose 2 than to gain 6. So I'm going to become plus 2 ions all the way down. These are, again, fairly reactive, and of course never found alone in nature because they react with just about everything they're going to come in contact with. 3 through 12, the transition metals. These guys are fun because they change colors. And if you think back to our flame test lab, a lot of the metals that we chose are, transition metals. This group 3 through 12 thing is something that I'm still having trouble getting over. There used to be a Roman numeral on this group for a long time, and then what they did was the main group that's up top, the whole lithium, all the way through boron and carbon. Those used to be the A groups, and then this was the B group. And so then they just decided to change the numbers all the way across. And so it just makes it tough for me. But we'll call it groups 3 through 12, and I'll stop, middling and muddling around. They're in the middle of the periodic table. It's called the D block. They form colored ions, or you could say they form colored solutions in water. That's the main thing that they're known for being able to do, okay? This concept is always on the Regents exam, and it really is. And it's this colored. It changes color in water. That's what they're really looking for pretty much every year, at least one time, okay? They tend to be very unpredictable. They will lose electrons or they will gain electrons, because, they're metals. And what makes them really kind of unpredictable is where are they? Are they on the far right or are they on the far left? And they tend to react differently as I go from one side to the other. All right. They are the least reactive group of metals. True, because they tend to have more than 1 or 2 valence electrons. So that kind of gets, muddled up in how they're going to react. Group 13 through 16. Would also be what I would call group 3 through 6. The BCNO group. So if you look at the top of the periodic table, you got boron, carbon, nitrogen, oxygen. Those are 4 elements that go across period 2. We just call this the BCNO group. It's not really a single group because there's a lot going on in this group. I got metals, I got non-metals, I got the whole metalloid staircase thing going on, and there's just no one way if I look down that one particular group that's everything acts exactly alike. So this one's a little bit ambiguous, if you will. But 17 and 18, we're going to get right back into these families where we need to know the names. They're all going to act just how we want them to act, like alike. 17 we call the halogen family. Everybody's going to have 7 valence electrons. So again, I have 7 valence electrons. I want to get to 8. Do you think I should gain 1 electron or lose 7 electrons? This chain, it's easier to just gain 1. So that's what we do. And I'm going to have a -1 charge when I do that. And then remember, of course, 8 is great. So I'm end up going to form salts and compounds usually, right? And because they are halogens, we'll call those halides. We'll go deeper into that in bonding. All right, contains the most reactive nonmetal, which is fluorine. All right, all nonmetals in this group. There are 3 states of matter in this group, though. There is a solid, a liquid, and a gas. An example, chlorine. Chlorine is a gas. Okay, the liquid is bromine, and the solid is iodine. And I should put an S for solid, sorry. So there is another quick question that you find a lot, where one of those little tricky, sneaky questions. They say, which family contains all 3 phases of matter? Well, boom, it's halogens, because this is the reason why we just explained. There's a gas, a liquid, and a solid in halogens. And that's one of the other things that makes them unique. All right, on to the noble gases. The noble gases, I like to think of the kings and the queens. And how often do we know that the kings and the queens come down into the town and mess around with the common folk? Not very often. Because they tend to stick to themselves. And guess what? This whole thing tends to stick to themselves. They're very unreactive. In science terms, we call that inert. They already have a stable octet of 8 electrons, so they don't want to gain any and they don't want to lose any. That makes them very stable, and they hang out by themselves, which is what happens to kings and queens a lot, because they get a little snooty, you know? They don't want to hang out with you because you're not royalty. The exception to the octet rule, of course, is hydrogen, because he can only have 2 in his s orbital. Otherwise, everybody else has got 8 and is doing great. Neon is a fine example, a gas that we see in the signs all over the place when we're walking down the street. Hydrogen is the lone oddball out of all this. Of course, he is not officially in a group. He is both a nonmetal and a gas, and sometimes he does even act like a metal, believe it or not. He can be seen as a positive ion or a negative ion. This whole lanthanide series is that big series on the bottom that is like pulled out, and I know we've talked about it a lot, how if it was stuck up in there, it would make the table look all kind of goofy. These are actually belong to the transition metals, and we don't talk about them too much, except for, most of them are, some of them get radioactive. There's some, uraniums in there, and then after that, we kind of leave it alone. So you got practice to do. You rewatch the video if you need, of course, or just use the notes you just took, and you can do these practice questions and, of course, these practice questions. I want to see those done in class. Also in your practice packet, you can do 13, 14, 25, and 29 now. And now we've delved a little deeper into what is a group, what are their names, and what makes them so special. See you guys tomorrow in class.